PCs, smartphones, and tablets are often looked at the pinnacle of human civilization. This technology helps drive our everyday lives and entertain us in various different ways. But what if I told you there's a more important device that's hidden in your mouse, in your keyboard, parts of your computer, your microwave, your fridge, even? These pint sized powerhouses run the world. These are embedded in everything from your coffee maker to the International Space Station. Devices are more impactful to your daily lives than anything else. Well, excluding food. You need food and water. Other than that, it's pretty important. So these are even more impactful than the phone and personal computer. Hell, these guys actually build computers and your phone. So let's buckle up and let's explore the microcontroller. What is a microcontroller? It's a compact integrated circuit and is often referred to as either an embedded controller or microcontroller unit or MCU. So what they call an embedded controller is it's inside your device, embedded in your mouse. It's embedded into your keyboard. It has a large degree of use cases and operation. They sell a lot of these. So in 2021, they sold over 30 billion of these units worldwide. And when you think about it in your everyday lives, you use these across the board for everything. Your keyboard, your mouse, there's some in your PC. You know, you go down, you sit down and you turn on the TV. You're using a microcontroller. Comparison, the x86-64, which is your basic PC processor, they sold 471 million in that same time frame. So when you look and see microcontrollers, they can also be annotated with a undercase U with the tail. I forgot what those are called, and a C. So just like your PC and your cell phone and your tablets, the microcontroller also has a central processing unit inside of it. So the typical instruction set, or at least the first one that was used, was 8051. It has also been expanded to different other instruction set. In particular, there is an ARM-based microcontroller that uses the RISC or reduced instruction set computing. Believe it or not, they still make these guys in 8-bit. I mean, that was pre-Nintendo era, I know. And then 16-bit as well as 32-bit. At this time, I am unaware if anybody actually makes a 64-bit. I can see that coming though. These devices aren't as powerful as your normal PC. All right, what do these microcontrollers do? They do a process where I like to refer to it as a sense or detect. So it takes in an analog signal from the world, or it could be digital. There's a threshold there where analog and digital is cut off. That's for a later video. It takes that in and then it processes that signal, makes a determination on what the state of that signal is. Well, it goes through a processing step. And what this does is it takes that input and determine what course of action needs to happen when it receives that command. And then it does an actuate step, forms an action, makes and reacts based upon that input and that logic. One thing unique about microcontrollers is they can accommodate all forms of communication in the digital and analog world. Are used for simple functions. You have more powerful microcontrollers that can perform a multitude, hundreds, thousands of functions at a time. Let's go over a use case here. We have the typical TV remote. It's got a power button. It's got various inputs, and it actually has an output. You can actually see it go. So one thing about controllers not a lot of people know is this puts out an ultraviolet light. We normal eyes cannot see this light, but input devices into the digital world, like your cell phone, cameras, they don't filter them out. So you can actually see what's going on when you push the button. When you push a button on the controller, it actually wakes up the microcontroller. It's held in a very deep, deep sleep until you request an action to be performed. During that time, it draws little little power. So once you wake up, it performs that action. It processes that information. If you hit the power button, it'll wake it up. It'll process that information and then it'll turn on your TV. When you take a look at a microcontroller, you take a look at a CPU, this microcontroller is so less powerful as far as computing wise than the CPU. So why would we ever use this device? So we look at computers and they're specifically designed to live in the digital world. Okay, give me a minute. Computers are specifically designed to live in the digital world, pretty much used for general purpose computing. So, what I mean by living in a digital world, everything that it interacts with, your inputs, your outputs, the Ethernet, it's mostly all digital. The only exception is really your mouse and your keyboard, but those are actually microcontrollers that turn it into a digital signal that brings it into your PC. It's all digital, mostly. Microcontrollers, in comparison, are designed to function in the real analog world. So most of the time, they serve to fulfill a specific function. These are easily programmable, reliable, and affordable. They've been adapted to live in a more harsher environment, allows us to use it in the extreme cold and the extreme hot. Here is a consumer grade microcontroller. So this has already been built. This is the Arduino Nano ESP32, and you'll receive it just like it's shown. So it has various input and output pins that provide a specific function. On the left there, you see a whole list of different analog signals that can be brought in or taken out. You have various different functions here that you can use. The one downside of this device is it's not plug and play. It's not like a USB where you can plug everything in and it'll work automatically. This is where you get into the whole world of programming. There's various amounts of libraries out there that'll help you out. Other downside is these GPIO on this board are not protected. If you don't configure everything right, if you don't set up your circuitry right, there's a high probability that you're going to bust these pins and your microcontroller will become trash. Don't trash the microcontrollers. These are important devices. Don't let me catch you burning these out. I've never burnt one out. Actually, I've burnt a few of them out. Or let's do a side-by-side comparison of a microcontroller and an x86 64 processor. Operating frequency of the x86 vastly outperforms the microprocessor. Generally can have up to 6.2 gigahertz, while your microcontroller only has 500. The x86 is currently limited to only 64 bits. I don't see that changing. I don't see it getting more or less anytime soon. While the microcontroller can have 8, 16, or 32 bits. For example, I wouldn't expect your controller for your TV needing anything more than 8 bits. Same thing with your mouse. I don't think you need any more than 8 bits to perform those actions. That's kind of why that processor can have such less data go through it, because it's not warranted in some operations. So the primary memory source on your x86 is solid state drive or a hard disk drive. Anybody still using those hard disk drives, you know what I'm going to say. And then finally, the microcontroller has a flash memory. So the x86 is generally just a processor. All of them have a graphical process unit inside of them. But other than that, nothing else. But when you get a microcontroller, it is known as a system on a chip. Everything you get inside of there, you'll have your flash, you'll have your RAM. Everything's built into the chip that you need in order to function. If you get a microcontroller, in general, you can make them small like this if they're used by the general public and don't have a specific function assigned. The only thing you have to do is provide power, ground, and a communication source into this chip. There's one thing you can do. You can get inside the microcontroller world and actually start using these. So, what are some of the tips that I recommend for you? So, first of all, I'd use a pre built microcontroller board like an Arduino. Well, these often come with open source libraries that has the vast array of helpful tips, software, hardware schematics for you to set up and utilize. GPIO that are designed to interact with the world do not have a method to protect themselves. You got to have a basic understanding of circuitry or really good at following the step by step guides available online. If not, you can actually burn out your GPIO pins and make your microcontroller useless. So, GPIO are not designed to drive specific loads. And what you'll want to do here is to drive it directly to a MOSFET or a specific driver circuit. One other thing is I'd learn first how to read and modify code. You get that far, you can at least upload that code into the microcontroller and make it run. They have various kits out there that have an array of functions and switches and electric components you can play around with. You put them in the board, follow the schematic, you follow the tutorial, you put them in there, you run them, and it works. Do that slowly over time, and you'll expand your knowledge, and eventually you'll be a mastermind of using the microcontroller. Use pre-built modules. You go to Amazon, you go to Adafruit. They have a whole variety of different components you can plug into the microcontroller. Just do it step by step. Learn one thing at a time, and eventually you'll be able to run a microcontroller successfully. Make a remote control car. Oh, they even have remote control car kits. Follow tutorials. If you want to get into it, I'd get into it. I appreciate you joining and watching the video through and through. If you like the content, hit a like button. If you want to see more content like this or anything technology related, hit the subscribe button and have a wonderful day.